Today, more than ever, positioning applications require the utmost precision, reliability, and security.
At u-blox, we are fully committed to continuously lower the barriers to adopting high-precision positioning technology. We strive to make it available to everyone. With this, we are not just advancing technology, we are democratizing high precision across all industries.
So, hi guys, hi everyone, and very warm welcome to our u-blox webinar here today. It's great to have you all with us today, whether you're joining live or catching a recording. It's great to see such a high interest, a strong turnout for our webinar. It's a sign that high precision is clearly a topic that's top of mind for many of you, and telling us that centimeter level GNSS is no longer a niche thing, but indeed on its way of going more mainstream. So today's session is titled Democratizing Centimeter Level GNSS Precision for All Applications. And that's exactly what we are here to talk about, how high precision GNSS is evolving, becoming more accessible, and enabling new possibilities for you across industries. So we will cover market trends, we will cover tech innovations, and for us here today, that's very much the introduction of the ZX20P, the X20 platform in general, and our new PointPerfect services, where we will look at real-world use cases and the performance together. Throughout the session, you are most welcome to drop your questions in the chat, and we'll be answering them the best we can as we go. Before we dive, let's introduce ourselves. My name is Morten Ström. I work as a director in the positioning product strategy team, do line management for industrial market, and have a focus on high precision, a focus on customers that demand that little extra from our products and performance. So that's me, and over to you, Ari.
Thank you, Morten. So hello everyone, nice to meet you all. My name is Ari Kuukka. I work here at u-blox as the product manager for the PointPerfect correction services family. As a webinar attendee, you'll be receiving a thank you email after this webinar. The email will have two links, exclusive links just for you. The first link is a special offer for the EVK X20P evaluation kit. It will take you to a DigiKey store where you'll get a $100 saving on the hardware, so you'll get it for just $199. The link will have a 2 weeks lifetime to take advantage of that offer. The second link in the email will take you to a 30-day free trial for the PointPerfect Flex GNSS correction service. That link has no time limit on activation, so you can try it out now or later on. And we hope that this will help you to explore our high-precision GNSS solutions more easily in your own projects. With that, back to you, Morten.
Yeah, so thank you, Ari. Let's dig into the topic of today. We talk about democratizing centimeter level, and here a section about centimeter level GNSS precision for all applications. There's quite many of us that's been in the industry for quite many years, and GNSS, I think it's still interesting. Well, 10 years ago, you might have thought that this is done and dealt with, that there's everything that was needed to be done was done. But since then, we have seen the introduction of new concept, Galileo, Beidou entering the field. We see new services evolving, and we see the receiver technology evolving, and we see the markets evolving. We see the application, market adoption, application growth continuing. So it is quite ongoing and continuously expanding. And now there is these new possibilities. There's new possibilities for centimeter and high precision to go into beyond what's previously been seen. And the driver for this is very much coming from the market. Everybody that has been using navigation in an application knows that accuracy is a bit addictive. You got this and you want more. You always want more. And this is interesting for us, a challenge for us, but that drives it forward. But what's going on now in the market, in so many markets, is this trend towards automation. And if you want to automate anything, you better know that you don't. If you want to automate something that moves, you better know where it is. Better not. And to do that, to automate that, those kinds of things, you are served by reliable and high accuracy with good availability. That's what you're looking for. So that's kind of a situation where we are in, but we can reach it. We can do it here. We have so many of these things coming together, key enablers that unlock these possibilities we haven't seen before. As I said, we have the new constellation with new services. We have Galileo beta. We have GPS itself modernizing. We are still waiting for the GPS L5 to be turned healthy, but we also have the regional system, Quasi-Zenit, Beidou, Quasi-Zenit and Navig in India, of course, with interesting services. Quasi-Zenit stands out here with quite interesting services. They had the CLAS there, and they have Madoka, they have OSNMA also, so it's quite. But in general, all of them are still evolving and coming with new services. So we better make use of them and can take use of them. And we make use of them then in more and more advanced receivers. That's the role we play. We put out earlier, we embed more advanced technologies. The advancements in microchip technology allows us to embed more in the same package. And as we do so, we go for more affordable solutions, more power saving, less. The power consumption actually in X20 is lower than F9, just to make a point. And all in all, trying to make these new services, these new possibilities accessible to a broader audience. A big part of that puzzle is also the correction services. As soon as you want to go sub-meter, you need a correction service of sort. And what's happening here is that there are new companies being created for this purpose. There are old and new companies offering new services. The constellations themselves are providing these kinds of services these days. And as a user or a system designer, you have now, with all this being said, you have a quite broad palette of tools from where you can select the right components for you from each of these pieces. I could now here mention also antennas. For this all to come together, antennas so utterly important that you get the antenna right. And also here we have seen quite some involvement during the last few years, where multiband and now all bands antennas are coming available at quite interesting packages and price and performance. So also that part is there to serve us. So if you allow me, I take this step back and look a bit at the receiver end of it. Our journey, and much of this journey started with when we took and put RTK in a small form factor. We made this step in 2016. It was an important step for us as a learning curve. It was an L1 only receiver, so quite fragile on what kind of application it could serve, but it was an important stepping stone for us and possibly for you as well to see what can we do with this kind of technology and what does it take and what can it not do. Much of what it couldn't do was that it was so fragile, and hence the big step came in 2019 when we went multiband. And this, I'd say, really opened up the industry and the possibilities here. We put a very, quite successful F9P product there on the market, and the way you embraced it was humbling and very exciting to see. We could see that those and that application that would adopt it and take it, but I don't think nobody was smart enough to see all the applications we have seen since then, making use of multiband RTK. And with that came correction services and the multiband antennas, the options that became available there. And I point here to 2021 where we put out the PPP RTK service. So this is breaking out of the limited service areas that you get with the VRS service, and now serving broadcasted messages, SSR types of messages that are broadcasting, and in this case from the u-blox service over a whole continent. So this really also is a significant stepping stone towards mass market adoption and making use of this technology that results in centimeter level in a broad sense. And now we are here mid-25 receiving or outputting, making an all-band receiver available for you. All-band, so it's more powerful as a platform, but also this all-band comes with quite interesting implications, and it opens up the doors towards making use of PPP in a practical applications, and that then as a step opens up for global services. We can break out from talking about service areas and always being limited by that kind of discussion. But now we can talk about global services. We can, in this way, I see that OEMs can embed services and provide a more complete solution out of the box to end users. And in this way, it will be quite interesting to see what the markets and guys like you do with these kind of technologies and these kinds of possibilities. So we have come a long way, and here you see the u-blox receiver generations over the years. It started out with single band receivers, and the latest on that platform is the M10. Before that we had M9, and it was in conjunction with the M9 that we also received a much the already mentioned F9 platform, and since then we have released F10, which is a dual band platform focusing on the power sensitive low power market. So you see this kind of technology, dual band receiver, also being embraced in the mobile phone by consumer grade products. And not to say these days anymore that it's high precision, but they do it for other reasons. Even if much of their focus is on the lowest power consumption, the lowest cost, they still think they can afford this and afford the antenna that goes with it. Even if the benefits in performance is not that dramatic, but there's a slight improvement in performance, in navigation, but also then in availability, and also maybe addressing concerns about jamming. You have a redundancy there with the second band. But that's not what we are here to talk about. Now we have then introduced, so I could say multi-band platform, F9, it was L1, L2, and then part of the L5. So hence we introduced the phrase there, multiband. But the F20, which we haven't talked much about, it's been just recently announced, it's a triple band platform. So that is a complete L1, L2, L5, all those bands supported in F20. But the flat out solution then is X20, where we also include the the L6 support. And I then should say that that is kind of a twofold consequence of the L6, that it gets access to the correction services that transmitted on the L6, but also makes the performance that you can squeeze out of the PPP service quite interesting. So I'm saying that the PPP technology you will only find on the X20 platform. We need the L6 there to squeeze out the performance that is relevant for dynamic applications. And F20 will, with an L1, L2, L5, will focus on VRS, local base stations, and PPP RTK. And PPP only on X20. So that is the receiver technology. Then on the correction services, these here also in this part of the puzzle, we have to see an evolution and have seen an evolution. As soon as you want to talk sub-meter, you have to have a correction service. And major steps are taking place here. We see, as said, the GNSS constellations themselves starting to transmit these kinds of services. First one out was quasi-zenith on the CLAS centimeter level augmentation service transmitted over the service area of Japan. We support that with a combination of the F9P products with the Neo D9C module on the side. So that's like they are kind of a front runner quasi-zenith as a system. It's interesting to see what they do, and many others should follow. Galileo has done so in so that they put also out this kind of correction service. It's a PPP service, the Haas service, currently in initial service phase. And then we have also Beidou. We have Beidou providing a PPP service over China. It's a regional service over the China area. Madoka also their global service. So a lot for us there to follow up on and eventually support. But not only that, we also see the commercial services taking steps forward, both in the technology, the kind of services they provide, but also in the business models that are available to us as OEMs or system integrators. So what is going on here, the big picture, I feel, is that this problem of hooking up with a correction service is necessarily not left to the end user to solve anymore. But more and more going forward, I expect that we will see OEMs solving the problem, making the product that is launched towards customer, be those then wherever they are in the world, having the luxury of receiving a solution that is ready to use out of the box. So that's quite interesting to see how that goes forward. And the markets that we then talk about are quite broad. We serve all the industrial markets. Here are pictures of some of them: precision ag, ground robotics, last mile delivery robots, robotic lawnmowers, UAVs, heavy machinery, construction, so on and so forth. All of these are served by these new possibilities, the new services, latest receiver technologies. So there's a lot for everybody here to catch up with. I should say, and I have the next slide here to help me say it, that within each one of these verticals, you have different needs. Like this example here with precision ag. Within precision ag, there are more than a dozen different applications with different needs. Sometimes you are happy to have 25 centimeter accuracy. Sometimes you are asking for 2.5 centimeter accuracy. And then, depending on the needs, you have now a growing set of receivers. Also in our portfolio is growing. We will have, as I said, F9, F20, X20. You have a growing portfolio from where to select the right receiver. You have a growing portfolio of services to hook up with antennas according to needs. So if you talk wide, if you want to have a general receiver for precision ag, you're probably going to go with X20 and a PPP service with also possibilities to use a VRS, even local base station. But if you're more focused, a more focused application, a more niche application, you can optimize it for its usage. You select it. You pinpoint select the right receiver and right correction service and right antenna. And this way you have a more focused solution and probably cost optimized also while doing so. So you need to take a minute here to think of what are my needs. Often we are faced with, often when we ask customer, what do you need? They say 1 centimeter. Well, not necessarily so. Actually, the application might be happy with 5. So it can be worthwhile to take a minute to think through what are the real needs here and optimize the design according to actual needs. So let's dig in. Let's look at the actual product, ZX20P. This is our first product where we build on the X20 platform. We talk about the X20 platform, which is our newest chip on which we will build a variety of products. And we will serve the automotive market, we will serve the industrial high-end market, and we will serve the timing market with products building on the X20. So more kind of the high and mid-end markets that we will serve with these. And the first one, for good reasons, because we know that the industrial market is quicker than those others in adopting new technology, quicker design cycles, the quickest guys we find in the industrial market. So hence, of course, we put out the first product for the industrial market to serve you guys. And the first product to go is the ZX20P. It's targeting the industrial automation, high-end industrial markets. And we are now here in engineering samples with this product, and we aim to go to production by late August. Possibly it slips into September, but not more than that. So late summer or early August, you might argue, we are in production with this product. It is set out to, as I said, support all bands, L1, L2, L5, L6, including the including the L band capability, allowing you also to receive correction service over L band integrated in the chip in the module. So we, of course, carry over the RTK and the PPP RTK we already had in the previous generation, but here we have more power underneath the hood. You can see the shield lifted up there. Actually, the hardware beneath is quite neat and signals quality and signals that we are ready for volume markets. We trust that we have good quality in this hardware. Eventually, there also, the PPP. It is not in the engineering sample already. We look to put it out to you early next year, Q1 next year. We are looking to introduce the PPP support. We put a lot of focus on the security, even if we don't have time to talk so much about it today. We focus a lot of it. We have a root of trust here in this module. We will come with more and more features building on both RF security and security around a product like this. So the KPIs or key features here: all band, all constellations, industry leading single die, single chip design, robust hardware, the said form factor that you know, and probably will bring something else eventually, but said form factor is very well established and embraced, and here we have the same form factor and centimeter level powerful. You can see like the 25 Hertz update rate, RTK raw, that we announced in this product is kind of a sign of quite powerful processing power beneath, and we will make use of that when we go forward. End-to-end security we will talk also more about later. Here are the signals. I think, here you see the L1 signals, all constellations supported, also the regional constellations supported, and obviously a receiver like ZX20 sets out to support that. We support the L2 and the L5 like we have done in previous products, and now here the L6 is the new thing. I already said it, but let me repeat it. L6 here that you find on the X20, in the X20 family, and specifically X20P now in this case, is interesting in so that it brings the performance of PPP up to a level where it becomes interesting and a relevant alternative to watch out for and maybe use in your application. And more so does it hook up to, it is on this Galileo E6 where the Galileo Haas service is hiding. So having X20, we get access to the Galileo Haas service, and we get the signal or the band separation set out so that we actually can make use of the PPP so that its performance becomes relevant, be that Haas or PointPerfect Global. Here we also have the integrated L-band to make it easy to adopt a service like PointPerfect Flex or PointPerfect Global, transmitted over L-band. So then here, a slide like this to say, so what are the benefits of all band? Yeah, the obvious and short answer is, so I get all constellation and all bands. Well, okay, but why would you be interested? Because this, as a consequence, will give you the best availability of the best accuracy. You can stress the system a bit more and you still get good availability of the best possible accuracy. You get built-in access to the correction services, both on L-band as well as the PPP services. And again, it brings the PPP performance down to a level where it becomes a relevant option for many applications. Also here, the more bands, the more tools we have to do cross-checks, the more to bring integrity. We are better off fighting interference, RF interference, if we have yet another band to fall back to when the other bands would be interrupted. And here now an overview also of not only X20 but also F20, and looking at how these compare to the much talked about said F9P. all band, triple band, multiband, and you can see that we here now for the first time in u-blox history talk about sub-centimeter level accuracies. We knew that we possibly could do it in F9, but now we put it in data sheet for the F20 and X20. We talk about 0.6 centimeters. And here on the X20P, you also find the PPP. It is in development. It is not included in the engineering sample, but you have our commitment that we will bring out this soon. And there you also have the different services, PointPerfect Global, same story, coming early next year, both of these. As a final piece in the puzzle before I turn over to Ari is the antenna. When you talk about these kinds of, when you have the ambition to go down decimeter, or also actually honestly when you just in traditional meter level GNSS, pay attention to the antenna and you are better off. Particularly now when we talk about sub-decimeter, centimeter level, it is crucial that you have good antenna. We can help you with that for the all-band receivers. Our new antenna already in production is the OSNMA. It is included in the EV-kit package that you might hook up and buy now with discount in this promotion, and it's a good antenna. Try it out and compare to the others and maybe take it into your design. And with that, I hand over to Ari. Floor is yours. Take it away.
Thank you, Morten, and welcome to the webinar again. So with the next 10 or so slides, I'd like to walk you through the portfolio of different correction services u-blox is offering. And we'll discuss what's the differences between them, how to pick the best one, the most suitable one for your particular application. Let me first start with the general overview on what kind of requirements we see our customers have when they are building their own high-precision solution. Every solution is unique, there's a lot of variation, but typically we see customers requiring accuracy within a few centimeters, sub 10 centimeters, sometimes more than that. There's a lot of variation there. What comes to scalability, many of our customers are looking to build solutions and business cases that will scale into thousands of devices, even tens of thousands or hundreds of thousands of devices in the future. And the services need to support that. They need to be secure, robust, and help the customer to manage that kind of very large fleets effectively and efficiently. Looking at the coverage, we see customers more and more not just operating in a single country or countries, but looking to build their business on whole continents or even fully worldwide. So the services need to support that, help the customers operate in all the markets where they want to be. And from the commercial perspective, competition is high today in a lot of these applications. So the correction services need to support customer build their own business case. And we do that by providing flexible pricing models, different ways you can access the service and pay for the service to suit your particular business case as well as possible. Let's speak a little bit about go-to-market. So in today's world, there's a lot of competition. You need to get your solution out to the market fast to get your business case going fast. And the way u-blox can help with that is by providing the whole technology stack. So X20, F20, F9 receivers combined with the u-blox's PointPerfect correction services and providing expertise and support for all of that stack for you, starting from the go-to-market, your R&D phase, and all the way through the whole life cycle of your product. By offering this, we can help you get your solution, get your business going faster, get to the market faster, and help you scale. Let's talk a bit more about different use cases and different applications. So not every high-precision application is similar. There's a differences there depending what are you actually doing with your high precision. So there's a whole spectrum of different needs we see. Here on the screen, you can see this kind of spectrum looking across the performance requirements and the kind of market footprint that customers typically have. On the top left-hand corner, we have these high demand, high value use cases like, for example, surveying or heavy machinery use cases, mining, construction. Going towards the middle part, what comes to performance and footprint, we see cases like outdoor mobile robotics. Could be, for example, delivery robots operating in the urban environments, or, for example, robotic lawn movers or precision agriculture use cases. And going even more towards the right-hand side, towards more global cases, for example, automotive customers very often are looking for fully worldwide markets. We support this by providing 3 different correction services that cater for different needs and are supporting different use cases. Like seen in the picture, these services have quite a lot of overlap. They are quite flexible what comes to pricing, precision required, and we'll look at that in a bit more details in the coming slides. So let's start with the PointPerfect Flex. It's our traditional solution. It's been on the market already for some years. It provides a great price-performance balance. It's a very scalable, nearly unlimited to hundreds of thousands, even millions of devices. And you can access the corrections through different methods. So it's a great solution for mobile robotics types of use cases, precision ag, automotive, UAVs. For cases where customer is looking for really the best possible performance, 1 to 2 centimeter type of levels, we today offer a PointPerfect Live. It's a new service we launched a bit earlier this year. So high demanding applications like surveying, construction, PointPerfect Live can be a great option for you. Bit later, early next year, we'll be launching a 3rd flavor of PointPerfect that will be called PointPerfect Global. It's like the name says, it's a truly worldwide service. It's a great offering for customers who are operating all the markets or in all the regions, or who are operating in a very remote areas outside of the cellular coverage. And a bit more about that later on. So let's look a bit more details on the technical specs and how these services differ. Starting PointPerfect Live, it's a traditional network RTK service. So it caters for all the error sources, satellite clocks and orbits, code and phase biases, and ionospheric and tropospheric delays, using traditional OSR RTCM data format. With PointPerfect Live, you can get to this 1 to 2 centimeter level accuracies, like we will see a bit later in our demo today, and we converge into the RTK fix in just a few seconds. In the middle one, looking at the PointPerfect Flex, it's our offering that's been around for quite some time already. It uses a PPP RTK technology, advanced version of that, and we provide today corrections both in our SSR and OSR formats, using our own Spartan protocol or the traditional RTCM protocol. With PointPerfect Flex and u-blox receivers, you'll get to the 3 to 6 centimeter level of accuracies, typically converging in few tenths of seconds. PointPerfect Flex, it's available in Europe and USA, continent-wide. Also in Canada, Japan, Korea, Brazil, and Argentina, where we are expanding quite fast, as well as Australia. And then early next year, you can choose also PointPerfect Global, especially if you're operating all across the world, remote regions. It's PointPerfect Global uses PPP AR technology and provides a SSR type of correction formats. So we are correcting the satellite clock and orbit errors and providing the code and phase bias corrections. With PointPerfect Global and X20P, you'll get down to sub 10 centimeter level accuracies in a couple of minutes. PointPerfect Global will be available both through internet and satellite broadcast everywhere in the world. So looking the coverages, I think I covered most of this already, but PointPerfect Live available in most of the European countries and also in most of the key economic areas in USA. PointPerfect Flex, available continent-wide all throughout the Europe, all throughout the mainland USA. We're expanding PointPerfect Flex quite fast today in South America. So in Brazil, Argentina, we'll be covering all the key agricultural regions by the end of this year. Also Japan, Korea, Australia are covered by the PointPerfect Flex. And PointPerfect Global, like the name says, will provide a truly worldwide corrections anywhere in the world. Let's talk a little bit about total cost of ownership and what that consists from. So when you look at the full cost of your solution over the whole lifetime, let's say 5 years of your solution, the cost of correction service is one part of that. But there's another cost that's often a bit neglected, but that can be quite significant looking at the whole lifetime. And that's where u-blox and our Spartan data format can help you. So comparing to the traditional network RTK service accessed using RTCM protocol, Spartan format is a highly compressed, highly optimized for mobile data usage. That means that you can get your mobile data usage down by up to 90%. It's really significant difference. And depending on the use case, it can be a significant part of your TCO. So this is something that's good to also keep in mind when looking at the cost structure of your solution over the years. Wrapping up the kind of key benefits PointPerfect provides you and how we help you to build your business case. We help you optimize your operating expenses by providing these flexible pricing models that help you pay based on your usage, help you spread the usage across whole fleet of devices. And we help you optimize your mobile data costs. PointPerfect provides capabilities that help you scale efficiently into very large fleets, deploy and manage that kind of fleets with a minimal effort. And with a continent-wide, worldwide coverage, we can support you in all of your markets. We monitor and manage our service 24/7. We provide high reliability, so you can build your own business case, your own solution with our service and be safe. The title of our webinar was Democratizing High Precision. So wrapping up, how do we make that happen? We provide correction services for each use case. So no matter what's your requirements, you can use a flavor of PointPerfect that's optimal for you. And with X20, F20, you have a great solution there. We make it easy for you to get going, get to the market fast, and also we make it easy for you to scale your solution when your business starts to grow. We provide service covering the whole world, and also we provide you these flexible pricing models that help you build your business case and pay for the data only when you need to use it. That's the overview for PointPerfect Services portfolio. And just to remind you, for the participants of this webinar, we offer the webinar offer of $100 saving for the EVK X20P evaluation kit and also 1 month free trial for the PointPerfect Flex. You'll get the instructions how to access this offer in email after this webinar. So thank you from my part, and now I hand over back to Morten. Thank you.
Yeah, so thank you, Ari. That was good. Now we're going to go in and take a look at some performance of the combined receiver and services. I will start this with a video on a UAV. So let me start the UAV and let's look at that.
We want to collect data for our R&D, for performance analysis.
Yes, so that was it. That was the video. I have one slide here to summarize what we saw in the video. You see here on the right hand of the screen, you see the error components in the northeast down graph, where we zoom in a bit to bring better visibility. We zoom in on 5 to 6 minutes of this flight. And and this is from the PointPerfect Flex, the PRTK type of service. You can see here on the left side of the screen, you can see the statistics of the accuracy, the 2D 1 sigma 3.3 centimeters during this flight. So quite good result out of the PPP RTK service. For the very best service, you would opt for the PointPerfect Live, the VRS service, and the 2D 1 sigma would be 1.2 centimeter in this case. For the very, very best service, you might opt for a local base station, which we also serve on the X20 and F20 products. Not so super interesting to look at the very, very best results. I could have brought in like a local base station, or maybe static in perfect sky conditions with super good geodetic type antenna, but we typically concentrate on other things. We concentrate on making the best availability for you guys. We typically do our testing with our own antenna on MB2 now, and these kinds of more affordable antennas, you can say. But also looking then at the availability, like in this case, making sure that what is our performance when we stress it. And here, park the car in situations like this, where it's actually parked under quite heavy trees and quite blocked from one side. And you can see how the effect of this kind of geometry in that the north, you figure out in which direction the blocking is going on in so that the north component suffers quite a bit in this kind of environment. And that's typically true, that the environment more so than the dynamics has an impact, and the environment and things like this indeed take a toll out of the performance. But having said that, we spend a lot of time on it, and think we have a pretty good balance between having the right level of availability and accuracy. We are quite careful not to run into being too aggressive and having these false fixes we all hate to see. But we know that we are quite good here, and we have a good sensitivity and good raw data. And what we often see is that we are, compared to competitors, we are good in reacquisition. We typically reacquire both a good RTK float and the RTK fix faster than competitors. And this you can see on this picture, a very typical example when we, on the right side of the picture here, come out of an overpass, a highway above us. And even under that bridge, we have GNSS fixes, contrary to our competitor that is dead quiet. And coming out, we are in a good RTK float. You can see that accuracy is actually quite good out of that float immediately as we come out of the tunnel. And not too many epochs, 2-3 epochs later, we are in RTK fix mode, whereas for the competitor, it takes typically a few epochs longer. And the same thing happens on the next slide, now going in the other direction. Both us and this particular competitor has a good RTK fix going into the tunnel. Going in, they go quiet, but we output a rather good GNSS fix in this case. Throughout, we actually park in the middle of the tunnel for a good 5, even 10 seconds. We are in standstill there before we continue. And the same thing is repeated when we exit on the other end. You can see that the environment is slightly more difficult. We have buildings, multipath environment, but a very similar thing happens when we go out. Immediately when we hit the open sky, we have a good RTK float, and soon after, 2 epochs after, we are the green icons here, mind you, we are in RTK fixed mode. And I'm not quite sure that the competitor reaches fixed at all. They do eventually, of course, but maybe not in this picture. So that's good. Let's go forward to maybe what some might regard as the most interesting part here now. Ari already introduced the PointPerfect Global, the PointPerfect PPP service. I also indicated that this is something that we set out to support. So I'm going to show a first glimpse of what we see there. Before I do that, let me complement also with Galileo HAAS. I introduced the PointPerfect Global, but a word about Galileo HAAS also. So it is a PPP type of service currently in initial service phase, meaning it's not quite ready yet, but we can start to make use of it. It provides today already corrections for GPS, all the bands, all the signals, and for Galileo, same thing. It provides orbit clock and code today, and eventually it should also provide the phase biases. The phase biases are quite important for us when we want to have the very best accuracy. That allows us to fix the ambiguities. But even before that, we can use it in a float mode. So let's see what we achieve then. Eventually also it is said to provide ionospheric corrections over Europe. Currently it doesn't do that. Maybe coming next year, we are not quite sure about the schedule. But even so, this is maybe not so important for us. Having an L-band, an all-band receiver like X20, we are confident we can estimate the ionosphere quite well in the receiver. So we are not so... of course we use it when we get it, but we can live without it. It's the phase biases that we actually would like to see, then we can really squeeze up performance. What's so interesting about the Galileo is that the service is transmitted on the satellites themselves, on the L6 signal. So we put out the X20, we tap into the Galileo E6 signal, and we can pick up the corrections. Put the receiver out with antenna and you got it. So tempting, easy to use. So let's see what we can make out of it. It is the most interesting out of these free services for this reason, or for these reasons listed here, maybe I should say. It has a global service area. Being a PPP service, this is what you have. Corrections are being provided for three bands, so that's good. We want that band separations to be able to squeeze out a good PPP performance. It doesn't provide corrections for the other constellations, so only 2 out of the possible ones. And this takes a toll, we know then, when we go into dynamic and more difficult. In a practical application, you will start to see differences here. And to the extent that the commercial alternatives will be interesting for you. We'll see that more, not today, but later. I expect that we will see that. But more so about the Galileo still, the delivery channel is the satellite themselves, and this is makes it so easy to use. So it will be interesting to see what we can do with it, what performance we can squeeze out, and in effect then what applications where you can see that you can make use of it. So right here, that relatively good performance is expected when we have this good separation of the band, a triple band, all band receiver with also E6 supported. And here I have it then on this slide, what we currently see. So this is static, open environment, perfect conditions, but it's a starting point for us somewhere which we will build on going forward, going more and more into dynamic and more difficult environments. But we already in the lab saw it, we noticed that this will be interested, and now we see it also in the simple cases in real life situation. We see quite promising results of these PPP services. You see here a 24-hour test. It's early days for us, it's early days for the services, but it looks promising. You can see we take for example the 3D 68 percentile. You see that the PointPerfect global we reach 8 centimeters here during a 24-hour, and for the Haas we reach 11 centimeters. So both within the targets of 10 centimeters for the PointPerfect and 20 centimeters for the Galileo Haas. Actually, that is the horizontal, so I should talk about the 6 and 8 centimeters, even better. But this is open and static environment, so take it with a grain of salt. We need to polish the performance and make sure then that we also see this kind of, that we get an accuracy, that availability that is attractive for you in a practical application. We are working on this, and we expect that we will bring it out in the product Index 20P Q1 next year. So looking forward to that, and between now and then I think we will be able to publish more results also on this in suitable forums. So stay tuned. It's super interesting to see what we together can do with this. Going forward, I thought I'll say a few words about Galileo OSNMA also. We have not so much time today, but we have a lot of focus also being put on the security aspects of things, bringing integrity into the solution through our jamming detection and mitigation, and through our spoofing detection and mitigation. So we have there on the web, I think we have also, and then we have a good information on this, and we have the new jamming detection, which reports where you have interference. We have more bands to use and fall back in case there's interference on one of the bands. We use the others, etc. We continue to improve on all this. Galileo OSNMA is a gem of the Galileo system. So I just here recently, in the previous slide, we talked about Galileo Haas, certainly a gem of the Galileo system. And here we have the second gem now in the OSNMA and that's the second gem of the Galileo system. OSNMA is the first time here now we see possibility for civil users to authenticate the navigation message. So we kind of get an assurance that the message that we are receiving from the signal and eventually then putting it into use to output a position towards you is authenticated and correct, not tampered with. So this navigation authentication only happens on the Galileo signal. So in the most strict sense, we should only use the Galileo signals then and calculate a signal solution based only on authenticated signals. We can do that, we allow you to do it also, but in a more loose sense, we can actually use the authenticated signals and cross-check with other systems and other signals that everything is fit, and in this way get a much higher confidence in the solution for where we still use all signals and all bands, all constellations. So you can see here from this that it transmitted on the E1 and also on the E5, verifies the navigation data, and in effect then authenticates the position that we output to you. It is a very effective way against spoofing, adding a strong layer of protection free of charge and globally. In the most strict sense, you should also, or the host should also have a trusted time, so that you are also protected from record and replay attacks. There, we have a paper on this on the web, so read up on that and make use of it. And this is one piece of the puzzle. In this puzzle, bringing higher integrity to all of you, we have the tool set that we build on in the jamming detection and mitigation, and also in the spoofing. And in this spoofing now here, OSNMA is one piece of the puzzle. Other pieces here on the screen. We follow recommendations like the Department of Homeland Security. They have an allow list of what to look for in a GPS message. We also look for any abnormal situation. We make sure that there are no jumps in position, no jumps in time, and we do cross-check and also look for other things there in the signals and in the constellations to make sure that these are real signals. In the sensor-based, products with sensors integrated, we also do sensor-based spoofing, detection and mitigation, both. So that's it. I think I have here some closing slides. We have a lot of information already covered in this webinar, but time is short, so I will point you to our website to read up on our products. We have material on the platform itself. We have now the X20P in engineering samples. You find a data sheet, integration manual, interface specification, product summaries on this product in ES there. We have white papers here on various topics, and we will publish more there, also on PPP, so stay tuned. We have more technical papers there on RTK, PPP, RTK, etc. And we have, of course, the antenna information, or also data sheets, etc., and on the services, EV kits, etc., user guides. Go there, and I hope you find the information you need. Meanwhile, I hope we have answered the questions in the chat. I hope you had taken time to feed in your question. I already answered a few of them, and I hope I have been helped by my colleagues there during the last few minutes. So with this, I thank you. You will be sent an email then with follow-up and with the promo offering. So with that, I thank you for the attention for now on behalf of me and Ari, and wish you a good day and good luck with all your projects. Good luck. Thank you for your attention.